Why can a factory spit out thousands of identical plastic parts every hour and have them all fit together like they were cloned? Because injection molding is basically a high-pressure copy machine for plastic. You melt tiny pellets, inject the melt into a precision metal mold, cool it for seconds, then pop the part out. Think of it like a super-controlled hot glue gun shooting into a steel waffle iron, same shape, every cycle. An injection molding machine has two main halves. First, the clamp, which holds the mold shut with tons of force. Second, the injection unit, which melts plastic and pushes it forward like a piston. The magic is, everything here is measured: temperature, pressure, time, and position, so the machine repeats the same cycle like a metronome. Step 1. Feed and melt. Pellets fall from the hopper into a heated barrel. Inside is a big rotating screw. As the screw turns, it drags pellets forward. Heat comes from two places: heater bands outside the barrel, and friction as pellets grind and compress. By the time plastic reaches the front, it's not burning hot, it's a thick, honey-like melt. Here's the part people miss: the screw isn't just mixing. It also measures the exact amount of melted plastic for one part, or one set of parts. As melt builds up in front, the screw slides backward by a controlled distance. That distance is basically the machine saying, "I've loaded the next shot." Same volume as last time. Now the main event, injection. The screw stops acting like a mixer and becomes a ram. It drives forward fast, pushing molten plastic through the nozzle, into channels called runners, then through a small entry point called a gate, and into the mold cavity. This part happens in a blink, often less than a second, because speed helps fill thin details before the plastic starts to freeze. But filling the cavity isn't enough. Plastic shrinks as it cools. So the machine applies packing and holding pressure. It keeps pushing for a short time to top off material as the plastic contracts. This is how you avoid defects like sink marks, those little dents you see near thick sections. Pack too little, the part caves in. Pack too much, you can force plastic into tiny gaps and create flash, that thin, sharp extra plastic at the mold seam. Cooling is the slowest part of the cycle, and the reason injection molding is engineered like a science experiment. The mold has cooling channels with circulating water or oil, pulling heat out fast and evenly. Cool too quickly or unevenly, and the part can warp like a potato chip. Cool too slowly, and your cycle time explodes, and your cost per part goes up. Once the plastic is solid enough, the clamp opens the mold. Ejector pins push the part out, exactly the same way, every time. And here's the real reason it's repeatable: the mold is precision machined steel. The shape doesn't flex like a soft mold would. The machine hits the same pressures, the same temperatures, the same timing, and the mold cavity is the same geometry every cycle. When it's dialed in, injection molding is fast because the cycle is short and automatic. But if settings drift, you'll see it: short shots, flash, sink, or warping. That's why factories treat injection molding like controlled manufacturing, not guesswork. So now you know the secret. It's not just melting plastic, it's measured, pressurized, timed replication. What should we break down next? 3D printing versus injection molding, or how molds are designed with gates and vents.